Alright, hi everyone, my name is Vishal and let's continue with our data structures and algorithm series. Previously, we looked at the BigO notations and how to calculate the time complexities of our code. We saw some examples of time complexities O of n and O of 1. Today, we are going to see some examples of O of n square. To understand this, I already have a small example here. This function basically takes an array and then returns all the possible pairs of that array. For example, this one is array of two integers 1 and 2. The output will be 1 1 1 2 2 1 and a pair of 2. Now to achieve this output, we are having a for loop here, which is basically iterating over the elements of the array. It will run for n number of times, meaning it will have n number of operations. Now there is a nested for loop as well, which is also iterating over the elements of array and logging all the pairs, which means it will also run for n number of times and it will have n number of operations. But remember, this is a nested for loop. Every time the parent for loop runs, it will rerun all of the operations of its nested for loop, which means the total number of operations will be n cross n, which is n square, right? Now let's try to see a complex example and try to find out the time complexity of it. For that, let's move to code sandbox. So the problem statement is detect duplicate sums in an array. Basically, we need to find out all the duplicate sums of the possible pairs of an array. For example, we have an array of two integers here, 1 and 2, right? And these are their possible pairs. Out of these possible pairs, these two pairs are having same sum, right? Which is 3, and this is our output. For this problem statement, I already have a solution here. This solution is kind of a naive approach. Now we will just try to find out what is the time complexity of this. For that, we need to find out all of the operations that are being done in this program. The first operation is this assignment operator, so I will mark it as our first operation. The second one, you can see there is a for loop, which means this will going to run for n number of times because we are not sure what exactly the array length is, right? So I will just mark out all of the operations here. The first one is the assignment one, which will be 1, and then we are going to have some comparison here which will run for n number of times, which I will mark as n, and then there is an increment, also assignment as well, because this is similar to I is equal to I plus 1, right? So there will be two operations for n number of times, so I will mark it as 2n. Now there is a nested for loop as well. This nested for loop will run for again n number of times, right? So all the operations inside this for loop will be multiplied with n. So for that, let's just try to find out how many number of operations are there. The first one is this assignment one, right? Now this assignment will run for n number of times because of this parent for loop. So we will just mark it here as n multiply 1, right? And then plus we are also having some comparisons here which will run for again n number of times, and there is a parent for loop as well, so it will be marked as n multiply n. Next one is our increment plus assignment, so this will also look something like n multiply 2 times of n, right? And moving on to the next line, we are having a push method. Remember, pushing something to the array always has the time complexity of O of 1. Why? Because it's just a simple operation. We are just adding new data to the existing array, right? And then we are also accessing some array elements by using their indexes. That one also has a time complexity of O of 1 because it's just a single operation. We are just trying to access the data from the memory. right? So for this one, the time complexity or number of operations will look something like this. So this push method has a time complexity of O of 1, but since it is inside a for loop, it will run for n number of times, and since that for loop is also a nested for loop, it will just work for n square of times, right, which is n x n x1, right? So we can simplify it and write it down like n square, right? The next one is accessing the array element using the index, which also has a time complexity of O of 1, but since it is inside a nested for loop, it will also something look like n square, right? Sorry, should be 2. The next one is addition. Addition also has a time complexity of O of 1, but since it is inside a nested for loop, it will look something like n square. Now next one is again same, accessing the array element using their index. It will also be n square. We can simplify these as well. I will just write it down as n, and this will be n square, and this will be 2n square, right? Alright, so this was about our first loop where we were just trying to calculate the sums of all possible pairs. The next for loop is trying to check for the duplicate sums. The first for loop will have the same output, right? These are two, both are same. I will just copy paste it directly here. And the next this one is our nested for loop and also looks similar, but there is one extra operation, which is this addition. But to simplify it, it will also look same. So I will just write it down here in comments. If you want, you can change it to 2n, because now we are having two operations here. There is an assignment and there is an addition as well, right? The next one is just a if condition where we are just comparing two sums by accessing the array element using their index. This one has complexity of O of 1, this one is again O of 1, and this one is again O of 1, right? So there are like three operations, but again it's a nested for loop. These three operations will look something like 3 multiply n square, right? And next line, we are simply console logging and then trying to access the array element using the index, which has a time complexity of O of 1, but since it is inside nested for loop, it will look something like n square. Now to find the final time complexity of this complete function, we need to add all these operations. So this one is our first operation, and then next is our for loop. We can simplify it and write it down as 3n plus 1, which we can furthermore simplify it and write it as n only, because n can be anything, right? So adding anything will result it into n. Now the next one we can simplify, and we can see this one is like n plus 3n square, right? Which we can more simplify it and mark it as n square only, because n square is the largest one here and rest of this will not make much impact on it, right? And this next line will have 4n square, which we can further simplify it to n square only, right? Now we need to add all these three and it will be simplified to n square. Now this one is our n square. Now moving on to the next for loop, simplify it again, it will be n number of operations. This one will be n square operations, this one will be again n square, and this one is anyways n square. So the overall number of operations we are performing here is n square. So I will just write it down n square. If you add this one, it actually results into O of 2n square plus 1, which you can simplify to O of n square, right? Now let's look at the time complexity graph and let's see out of these time complexities which one performs well, right? So this is the time complexity graph, and you can see we are here on the x-axis having input size, and on the y-axis we are having CPU operations. You can see if we look at the time complexity of O of 1, right, this one is a straight line parallel to the x-axis, which means if you increase the input size, CPU operations will remain same, right, which is the best time complexity for any solution. And the next one is O of n, which is creating a directly proportional graph, which means when we increase the input size, the CPU operations will also increase, right, which is not so good but also not bad time complexity. The next one is O of x square, which is our O of n square. Here O of n square is creating a quadratic graph, which means if we increase the input size, the CPU operations will increase much faster, right, which is not a good solution at all, which is not a good complexity, time complexity for any solution. So we must try to avoid this time complexity. Alright, that's all for this video. In the upcoming video we will look at some examples of O log n time complexity and On log n time complexity. Alright, thanks for watching.